example. So you just continue like that. Alright. Log of x to the base 2 minus log of 4 to the base 2 is equal to 32. So the bases are the same. You got x minus 4, so you can divide. You can say log of x over 4 to the base 2 is equal to 32. Right. Now it's in log form, and you may decide to change it to index form. So you'll say, well, x to the 4 is equal to 2 to the index 32, because I'm changing it. Right. Now, when you look at this, you may say, right, that's x over 4 is equal to, that's 2 to the 32 all over 1. And then I can now cross multiply. X times 1, x is equal to 4 times 2 to the 32. X is equal to. Now that 4 is really 2 squared times 2 to the 32. Now maths is a beautiful subject. It doesn't get you bored. So if you're doing logs, it reminds you about powers. Now you know 4 is 2 squared, so you recall from power knowledge, right? And then this is, the bases are the same, you multiply, therefore x is equal to 2. Add the indices, 2 to the 34, and you can leave it like that. X is equal to 2 to the 34. So that's why it's called a beautiful subject, because it really takes you from one section to another section, and it mixes everything up, and you enjoy doing that. Alright, we're going to move on to number 4. Log of log of 4 to the base x plus log of 16 to the base x is equal to 2. So you'll see, well, plus, and the bases are the same, I can multiply. So log of 4 times 16 to the base x is equal to 2. That means log of 64 to the base x is equal to 2. Now it's in log form, bring it to index form. So 64 is equal to x squared. Right, now common sense tells you that, look, something squared gives me 64. So 8 squared gives me 64, you see. Something squared is 64. So 64 is 8 squared. Now, you can see, if the indices are the same, indices are the same. Therefore, equate the bases. Equate the bases means make the bases equal. Therefore, the indices are the same. Therefore, the bases can be equated. Therefore, the answer is x is equal to 8. Alright? And finally, we're going to do number 5. Log 16 to the index x to the base 2 is equal to 40. Well, maybe you feel like bringing that to the front. Well, that's a good feeling. So x is equal to log 16 to the base 2, which is equal to 40. Then you zoom out and you ask yourself, what can I do? Well, I can change base over here, you see. I can change base. So x log 16 over log 2 is equal to 40. See, I'm multiplying here. X times this is equal to 40. Now, I put that into the calculator. You take your calculator and you plug it in. You say log 16 divided by log 2 is equal to, and your calculator gives you the answer, 4. So what are you saying? You're saying 4x is equal to 40. X is equal to 40 divided by 4. X is equal to 10. So you see, it's really easy. You just have to keep applying the different laws, a little bit of common sense and a little bit of previous knowledge. Alright, we've got a few more examples. We'll continue the next time from number 6 to number 10. Right, number 6. Log of 500 minus log of 5 is equal to x. Number 7. Number 7, log of x to the base 3 plus log of 5 to the base 3 is equal to 4. Number 8, log of x to the base 2 minus log of 2 to the base 2 is equal to 32. Number 9, log of 3 to the base x, log of 3 to the base x, plus log of 27 to the base x is equal to 2. And finally, number 10, log of 64 to the index x to the base 2 is equal to 40. And where necessary, you must get the answer correct, like in the last one, correct to 1 decimal place. In number here, you must get the answer correct to 1 decimal place. All right. So those are the next 5 examples for you to do.